let's talk about synthetic division. I don't want to go over the easy problems. I don't want to go over the common problems that every teacher teaches or that you will see on your homework and your quizzes. I want to go over the types of synthetic problems that you can expect to see in your test. The ones that your teacher doesn't really have time to teach, but then they put it on the test anyways, and then expect you to know how to do it. Those are the problems I am after to go over to show you how to apply. So the important thing here is each of these problems is actually going to be divided by a quadratic, all right? And a lot of times when students look at synthetic division, they just remember, I only can do synthetic division when I am dividing by a binomial, which is correct. However, if we have a quadratic, we could also factor that into a product of two binomials. Then we're going to do synthetic division twice. Now, this process confuses a lot of students, and that's why I really wanted to go over this. So therefore, you guys can see how to do this and where not to make your mistakes. So if I have x squared minus x minus 2, I could use long division. That'd be perfectly fine. But if I wanted to do synthetic division, I simply just need to factor this into x minus 2 times an x plus 1. Now I need to do synthetic division twice. Now we need to choose which factor should I use, right? Because of these two factors, if this is broken down in these two factors, then we could, either one of them is not going to matter. They both potentially could be factors of our polynomial in the numerator. So what I'm simply going to do is I'm just going to pick one, okay? And I'm going to pick x plus 1. Now remember, when we want to find k, right, you just take your factor or your divisor, set it equal to 0, and you say x equals -1. Okay, that is going to be my k. We take that number on the outside, and then we go and set up our synthetic division little box. Then we're going to take the coefficients. Remember, if there's no number in front, it's assumed it is represented as 1. So I'll do 1, 2, -5, -6, okay? And again, let's just go through the synthetic division algorithm. Bring down the first number, 1. 1 times -1 is -1. 2, so multiply on the diagonal, add on the vertical. First one is always a freebie. 2 plus -1 is going to be a positive 1. 1 times -1 is going to be a -1. -5 plus -1 is a -6. -6 times -1 is going to be a positive 6. -6 plus 6 is going to be 0. And that, ladies and gentlemen, tells us it's a remainder, which is great. That means that this factor evenly divides into this polynomial. Okay, so here's where the mistakes happen. So now students are like, all right, I still need to go ahead and further divide this, right? All I did was I took my divisor and I broke it down into similar factors. It's like dividing by 12, but instead of dividing by 12, you divide by 2, but then you also have to divide by 6, right? Because 2 times 6 equals 12, right? If you just divide by 2, you're not dividing by 12, you're dividing by 2. Right? So we have to divide by 2 and then divide by 6, kind of that same idea or thought process. But here's the mistake that students will make. They take the other factor, -2, and then when they set up the synthetic division algorithm, they use these same coefficients again. No, ladies and gentlemen. Think about it. If I'm taking a number, let's say 24, and now I'm dividing it by 12, right? Or I don't want to divide by 12. I want to divide by 2 and I want to divide by 6. I don't take 24 divided by 2 and then take 24 divided by 6. Right? I take 24 divided by 2, and then that answer is 12, and then I take the 12 and divide that by 6, okay? So what that means is this is my quotient, right? This is my answer of dividing by one factor. I now need to take the other factor and divide into that quotient. So I'm just going to take these coefficients, 1, 1, and -6. So now, again, applying the synthetic division algorithm, bring down the 1. That's the freebie. 1 times -2 is a -2. 1 plus -2 is a -1. -1 times a negative, wait a minute, what happened? Did I go 1, 1, -6? Oh, that's a positive 2. Mr. McLogan, right? That's why you set it equal to k, right? You say x minus 2 is equal to 0, x equals 2, positive 2. So that should have been a positive. That should have been a 3. 2 times 3 is a 6. That's a 0. All right, now another small mistake. Most students understand this, but again, it can still happen. The last number is your remainder. The last number is always your remainder. Now this is 0. So what that means is this polynomial, x minus 2 times x plus 1, evenly divides into this polynomial. How many times does it do it? That's what the quotient is going to tell us. Okay. So the last number in the quotient is going to be our constant. And then this is going to be the coefficient of our linear term. And if you had more, then you could just keep on going higher and higher powers. Okay. Each of those numbers represent the coefficients of those values. So my final answer is simply just going to be a x plus 3. Now again, what does this mean? This means x squared minus x minus 2 times an x plus 3 is x cubed plus 2x squared minus 5x minus 6. Okay, That's what that is representing. Or you could say x cubed plus 2x squared minus 5x minus 6 divided by x squared minus x squared minus x minus 2 equals x plus 3. That is going to be your answer. All right. So now let's go and get into something a little bit fun, and that is going to be with imaginary numbers. Now, I will give you guys some context. I wanted to make this video just on doing synthetic division. And when I first started teaching precalculus, I used to go over this process with my students. And then I quickly realized that this was really a waste of time to do this with my students. I should just use long division. But my students hated long division. And so I would spend time, and these problems would take forever for me to go through them in synthetic division, but I would do it. But then quickly I was like, guys, no, this is taking too long. Just do long division. So if you want to do long division for this type of problem, by all means, that's the way that I would approve it. But I also know some students really kind of struggle with long division. So if you're ready just to push on through and do synthetic division, then that's what we're going to do. All right. So again, we have a quadratic in our denominator. So we have to take that. And we could factor this down in your head if you got it. Or you could use the zero product property to go ahead and solve. So not zero product, square root method. So x squared equals -1, take the square root, and x equals a x equals a I, right? The square root of -1 is I, which is our imaginary unit. You also could factor this into x minus I times x plus I. It just really kind of depends on your comfortability with complex numbers. Okay, so what we're going to do is we have two potential zeros. We have I and we have x equals a -I. All right. So what we're going to do is use synthetic division with imaginary numbers. Now, I will tell you, if you're going to do this, make sure you give yourself a little bit more room than what we did in the last example. I'm going to use as much of this space as I possibly can. Okay, because not only are you going to have real numbers, you're also going to have complex numbers. So when I'm writing in my coefficients, a 7, a 5, a 7, and a 5, I'm just going to spread them out a little bit more. Okay. So first one, that's a freebie. We love freebies, right? Bring it down. Come on down, just like the Price is Right. Then we're going to multiply on the diagonal, add on the vertical. So 7 times I is a 7i. Now I cannot add a 5 plus a 7i. So I'm just going to rewrite this in complex form, 7i plus 5. Now I'm going to multiply a 7i plus 5 times I. Now this is where a lot of students will make mistakes, especially on tests. They try to do this in your head. And yeah, ladies and gentlemen, you can do this in your head. That's perfectly fine. But if you have a scratch piece of paper, just use it. I am the student that would get all the problems wrong when I was a student because I try to do everything in my head. And even as a teacher, right? As I'm teaching in front of a class, I'm writing one thing, my brain's thinking another thing, and I just make mistakes. Okay. So just try to break up your steps if you can. 7i squared plus a 5i. What is I squared? I squared represents a -1, right? So therefore this is a -7. So this is a 5i minus a 7. Yeah, 5i minus 7. So we have a 5i minus 7. If I add a 7 to that, I'm just left with a 5i. Then 5i times I is, again, we can just write it out there. 5i times I is a 5i squared, which is, again, I squared is -1. -1 times 5 is -5. Boom. There we go. We get our 0. Now, again, you might be thinking, well, how the heck is my polynomial going to have imaginary numbers? Well, it's not going to have imaginary numbers, okay? What we have to do is do synthetic division again. But again, we're not going to use our original numbers, right? We are going to use the quotient from the first division. So I'm going to take 7, 7i plus 5, 5i, and 0, which is we're already done. So again, freebie, we love freebies. Bring that first one down. Multiply on the diagonal, -7i. 7i plus -7i is equal to a 5. 5 times -5 is going to be a negative 5i. Yeah, I don't know what I was doing. And 5i times -5i is going to be a 0. So again, this is our remainder, this is our constant, and this is our coefficient of our linear. So our quotient for this example is going to be a 7x plus 5. So that is how you do synthetic division with long division. But ladies and gentlemen, we're not done yet, because I know sometimes your teacher will do the basic with polynomial factors, then we'll have imaginary numbers. And guess what? There's one more that you should expect. And that's going to be with radicals. So let's get over question number 3, which would be like an x-5, x to the 5th plus 3x to the 4th minus 2x cubed minus 13x squared minus a 15x minus 10. And let's put that all over a x squared plus 5. Whew. Okay. Now again, you could factor this in your head, or if you're like, I don't know how to factor that, then just fine. Set your divisor to 0. Oh wait, do I want plus 5? Is that really my problem? Hold on a second. That was supposed to be minus 5. My apologies. I wrote that down wrong. We want to fix that. I'm not doing, you could use that, and that would be a great problem that your teacher could give you, but I didn't want to use it. You could do imaginary and a radical. I've given that to my students as well. But that wasn't my intent here. So if I add a 5 to both sides, I get x squared is equal to 5 square root, I do not know, x equals the square root plus or minus the square root of 5. Or you could think of that as factor form, x minus square root of 5 times a x plus the square root of 5. Okay. So again, you have your two, k's, your potential zeros, which is going to be positive square root of 5 and negative square root of 5. Just like I did with the imaginary numbers, I'm going to give myself a lot of space, okay? So take our coefficients. Again, we have a 1 here, 1, 3, negative 2, negative 13, negative 15. Remember, ladies and gentlemen, if you have a missing term, right, always use 0. You have to make sure you include that space value. So I have a 1, 3, negative 2, negative 13, negative 15, and a negative 10. Freebie, bring it down. 5 times square root of 5 is going to be square root of 5. 3 plus square root of 5 is just going to be a 3 plus square root of 5, right? Can't add those. Now over here, I'm going to have the square root of 5 times a 3 plus the square root of 5. Again, good old distributive property. So that's a 3 square root of 5. Square root of 5 times square root of 5 is the square root of 25, which is simply just going to be 5. So therefore, that's going to be a 3 square root of 5 plus 5. And negative 2 plus that is going to be 3. Do you see how all my stuff is getting kind of smushed? I should have given myself a little bit more room. But anyways, that's a plus 3. Okay, now I got to multiply this times the square root of 5 again. But again, like use a scratch piece of paper, right? I mean, don't make everything so difficult if it doesn't need to be. So over here, we can only multiply our radicals times our radicals. All right, so this 4 is square root of 5 times square root of 5 is going to be 5 times 3, which is going to be a 15. And then that's plus a 3 square root of 5. But I'm going to write that above that. So it's a 3 square root of 5, and that's plus 15. I'm going to put these in parentheses so you guys can see which ones are grouped with which. Okay, now negative 13, I can only add that to a 15, which is going to be a positive 2. So that's going to be a 3 square root of 5 plus 2. And then I'll multiply that again. So I have another square root of 5 times a 3 square root of 5 plus 2. And again, you can see how long this will take going through this in class. And some students are like, totally get it. They're bored because like, this is just boring. And then some students are like completely lost. Like, what are we doing here? Like, why are we doing this? So I think that's why long division, guys, it's just be so helpful. Anyways, so square root of 5 times square root of 5 is going to be 5 times 3 is again another 15 plus a 2 square root of 5. I'm just going to rewrite them though. So the square root is in front. So 2 square root of 5 plus 15. Hey, those 15s are going to add to 0. Leave me with another term. You're not multiplying. I'm just trying to group them so everything doesn't look so confusing, okay? Just group everything like that. So then I have a 2 square root of 5 times 5. And square root of 5 times square root of 5 is going to be 5. 5 times 2 is going to be a positive 10. And that, ladies and gentlemen, is going to be 0. Whew. Okay, so let's do it all again. But again, I'm not going to take the original coefficients, even though I really want to, like I want to do with numbers, but actually I want to get rid of these radicals, okay? So I'm going to take this quotient. So it's going to be a 1, it's going to be a 3, oops, plus a square root of 5. It's going to be a, oh, why did I do, oh, all right, whatever, I'll just do it with the numbers first. And then it's a 3 plus a 3 square root of 5. It's going to be a 2 plus a 3 square root of 5. You don't need to rearrange these. I'm getting confusing and I'm writing them. So preferably you can write them either way that you want, but I'll just write them now with the numbers in front. So again, freebie, we love freebies, right? 1 times negative square root of 5 is a negative square root of 5. Hey, look, the square roots are going away. That's going to give me a 3. 3 times negative square root of 5 is a negative 3 square root of 5. Hey, look, those add to 0. Give me another 3. 3 times negative square root of 5 is going to be a negative 3 square root of 5. Hey, those go to 0. Left with the 2. 2 times negative square root of 5 is a, hey, here we go. This is awesome. Okay, so that's our remainder. This is our constant, coefficient of our linear, coefficient of our quadratic, coefficient of our cubic. So our final answer, our quotient, is going to be an x cubed plus 3x squared plus 3x plus 2. That means x squared minus 5 goes into this polynomial. X cubed plus 3x squared plus 3x plus 2. That means this times this equals that. So there you go, ladies and gentlemen. Hopefully you are ready for your test. I wish you the best of luck. If you are not ready for your test and these are way over your head, then go ahead and check out my description. I have many, many more videos going through the synthetic division process, as well, again, as some practice problems that you can use to get better at synthetic division, long division, whatever you need in math for polynomials. Or you can check out the next video I'll have for you here. Cheers.